Ken here. I'd like to take a look at some venting and ventilation. And the module that we're diving into right now is actually combines venting and ventilation. Two of them that really should be together, and it's good that they are together because one cannot be without the other. So we're going to start out with an introduction and we'll proceed. So there is a set of questions. I don't know if it's going to allow you to do this, but you could, if you have them either in paper copy or whatever, you could write them out, type them out, however you want to do it. So, but there is a set of questions that goes along with this. So let's get it started. So first thing I was going to point out is that most new appliances today, they are built with some sort of a mechanical venting system. So if it's a, we oftentimes call it an induced draft type of a system. Now, it doesn't necessarily have to be, but that is the way a lot of those appliances are. There are still hundreds of thousands of systems out there that do not use an inducer motor. So understanding venting for any system that would require and utilize natural forces is really relevant in our field. The other thing that I want to point out is just because an appliance is mechanically vented or induced draft does not mean that it is not using natural draft forces. So the venter may only be used quite possibly to just overcome the resistance of the furnace, and then you're still relying on the venting forces, all natural forces to allow those products to get out of the building. So we'll proceed. So exactly what is gas venting? So the first thing that I would say is venting is really when we look at the process of how do we get what we've just done for combustion, how do we get that out of the building? Now I said house in here, but it could be a commercial building, whatever it might be. We just need to get them somewhere else, probably outside most likely. When we look at, obviously we know what venting is, but what it goes into venting, what are the products? Well, we know that there's combustion air, and we have to have combustion air in order to burn properly. So essentially the combustion air is really considered any of the air that is needed to completely burn that fuel into proper combustion. So we always kind of look at one of them as being one of the Kmzintas, and where does that come from, and which one is the Gezaudas, and where does that go to? So let's take a look at that. So the first one, the Kmzinta, is essentially the combustion air that would normally come from outside. Now I want to point out that this also could be, combustion air could also be used as dilution air. It could be used as some of the other types of air that is needed to operate or to allow a furnace, a boiler, to function properly. So it's more to it than just what's used to burn the fuel even. So where does the Gezauda go? So that's essentially what has to go outside, and that's essentially pretty typical, I guess. We'd expect that. So let's take a look at it. What are some of the problems that we have with venting flue products? So the first thing that I would say is the fact that we're looking at the volume of these flue gases is up to 37.5 times greater than the volume of the gas being burned. So we know from when we burn combustion, if we take a cubic foot of natural gas, and that could be natural gas, we could even look at it as propane even, but if we take a cubic foot of gas, we know that we need a certain amount of air for combustion, and part of that process is going to be the energy that is needed to get that to vent properly. So we know that there's a huge volume of gas that has to be vented. And this could be dilution air, this could be combustion air, this could be in the form of excess air, however you want to call it. The other issue is the water vapor. And the water vapor that's in those flue gases is fairly acidic. And a lot of times tests have shown anywhere from a 2 to about a 5 as far as the acidic nature of that. So that becomes a little bit of a problem because the venting materials have to be able to handle that. So back to number 2 a little bit on the energy side. When we get that draft started. How do I get this draft started? How do I get that energy going? And it takes heat to do that. So that's the challenge. These are the three areas that we have to deal with: is the volume, the water, and of course the energy. So let's take a look at what changed. So over the years, we had appliances that maybe weren't quite as efficient, and maybe they had a lot higher gas temps in the flue. Some of the really old ones, they had 1,000-degree flue gas temps. Now that today, any appliance today, you would never really see that. You might see it be 400, 500, 600 degrees, but that's about it. If you look at a lot of those, even a gas or wood appliance, obviously that was any of those appliances. I put coal, gas, wood, oil, any of those. Anything that's a lower efficiency, there's some characteristics about that. So let's take a look at that. So the constantly on is one thing that I was going to point out. So in other words, you're really never cooling down that much between those cycles. So the chimney really never gets cold. It's always warmer than the environment around, and that was one of the characteristics because of the enormous amount of heat that was in that. The other thing is obviously with that high flue temp gases, it just makes it so much easier to vent. And then obviously with the buoyancy as a result of the higher vent products, so the higher temps in the vent products. And then because of those high temps, it's a lot less likely to condense. So that's the reality of what the older ones. So let's take a look at it. So how are gas furnaces, how are they different than the older, less efficient? So how is a newer unit a little bit better? So let's take a look at it. And maybe it's not necessarily better. It's certainly better from the efficiency standpoint, but it may not necessarily be better for the venting. This is the biggest number one challenge of any type of mid-efficiency appliance that we deal with. So the first thing is the intermittent cycles. So when we put an appliance in there, there's not as much residual heat. So when they're intermittently cycling, during that off time, the chimney can cool down a lot more. The sizing of not only the furnace, but the sizing of the vent system becomes way more critical. Those lower flue gas temps is the other issue. So obviously more efficiency leads to lower flue temps. So the much lower flue gas temps, and typically we would expect to see 400 degrees or less on most mid-efficiency appliances. They don't vent as easy, and that's one of the issues. The other thing that I would point out is also that they're way more likely to condense. The closer you get to that dew point, they're going to be much more likely to condense. Now, the other thing that I would point out as well, a lot of those newer appliances that are induced draft, they don't really have any dilution air. If I have a boiler in the field that is not induced draft, but it might be a natural draft boiler, that boiler will have dilution air. And again, that one, even though it's more efficient, it's also going to be less likely to condense compared to a mid-efficiency induced draft furnace. So these are the characteristics. All right, so let's take a look at the four categories. So when we start looking at a vent system, there's really four essential categories that have some very specific details. You must know these categories because it's so relevant to how you vent them and what makes the rules, all those types of things. So really the specifics that are mainly important are essentially understanding the vent pressures to expect, as well as the vent temps that would be relative to the gas dew point. So that's kind of the first one. So the first one I want to look at in this case is going to be a category 1 type appliance. So you'll notice on the chart that's shown on here, this category 1 appliance is going to identify essentially 140 degrees above the dew point, and it's going to be natural draft, also negative pressure. So let's take a look at what that's going to be. So a category 1 appliance essentially is going to have that flue temp, or the flue gas temp, is going to be greater than 140 degrees above the gas dew point. Now you have to understand where would the gas dew point be. So, and that can vary. Typically, our gas dew points could range anywhere from 120 to 130 to 135 degrees. And it'll vary obviously depending on on the flue gas temp that we're running, as well as just the efficiency of the appliance. I'll talk more on this a little bit later, but definitely a negative vent pressure. It's essential to recognize that. So let's take a look at the next one in a category 2. Now, the first thing I want to point out is category 2, that's down in this area here. Category 2 is a negative vent pressure system that would have a flue gas temperature that would be less than 140 degrees above the dew point. I'm not aware of any appliances that have ever really been successfully created in commercial markets that would allow that to work. You just don't have enough energy to create, to basically properly create a negative vent pressure. So when we take a look at those details on this system here, a negative vent pressure less than 140, those are the two significant details. We won't be doing any types of problems that would relate it to type 2 just because there aren't really any that I'm aware of. Let's take a look at the next one. So of the other of those 4 categories, there's such a thing called a category 3. And a category 3 appliance essentially is going to be a system that it has to be an airtight type of a vent system. It's going to have a fairly high temp. Now, there's actually quite a few appliances that are considered as category 3. All of the category 3 appliances are going to have an inducer motor that not only has to overcome the resistance of the furnace or the boiler, but it also has to have enough pressure built up and enough energy in its process that would allow it to push those products and overcome the resistance of the vent system. So that's kind of a big characteristic. So positive pressure, it also has to have a flue gas temp that's essentially greater than 140 above the dew point. So we don't typically associate this with a condensing system. This would typically be a non-condensing type of a system, as you can see based on the image that's shown in here. Oh, one other thing I want to mention. Specifically, all of those, the manufacturers of category 2, 3, and 4, all of their specific installation, specific details that relate to the venting, the sizing, maybe even how it's put in, those all fall on the manufacturer. Now, the gas code book could indeed give some insight on it, but that's one of the big things. That the manufacturers, you have to follow their rules. All right, category 4. So the category 4 is probably the one in the market that we're in Wisconsin. In any type of a northern climate, we push a lot more category 4s simply because of the efficiency and, well, let's just put it this way, it's more efficiency and they fit our needs much better from a cost standpoint. So if we take a look at these, the other thing that obviously I just had mentioned about the sizing details, things like that, those are all specific to the appliances. Now, a couple of things that you have to have. As you guys would probably guess, if it's a category 4 appliance, typically our concerns are the corrosion, so that you don't want your vent system to corrode. It has to be an airtight, a completely tight vent system that allows those products combustion to get out of the building. The other thing that we typically would associate this with is condensing, but it doesn't necessarily have to be condensing. So the rules of this one would be a positive vent pressure. It also means that your flue gas temp would normally be 140 degrees above the dew point at the most. So it's going to be less than that. And it can be condensing. You typically would think that they would be, but it absolutely does not have to be that way. All right, so let's take a look further on this one. All right, so on the 4 categories, to kind of recap a little bit here. So, why would we care about a category? Why would we care about the 4 vent categories? And a lot of this, I think, to some extent, is in the selection of those materials, the installation that's specific to them. So any type of a system in a category 1 or 2, when you see that it's a negative vent pressure, The one thing that I would associate this with is I typically, because of that negative vent pressure, my vent products don't have to be completely sealed up like it would be for a positive vent pressure system. I don't worry about the gases leaking out and getting moisture to leak out of that system. Generally, that's what we would typically associate with that type of a system. Now, obviously, a category 2, you'd be more concerned about a condensing type system, but as I had said earlier, I don't anticipate and I don't know of any systems that are out there that are like that. Let's take a look at specifically on the category 3. Category 3 and category 4. Now, as I had mentioned earlier, I said these were positive vent pressures. So the positive vent pressures are, you've got to have whatever your vent system is, it needs to be sealed up. That might mean that you might be using a high temp silicone. You might be using, you could be using some sort of, oftentimes they refer to that as RTV silicone. You might be taping your joints. It depends a little bit on that. It has to be able to handle the heat that would be associated with that. And the other thing that you have to also be concerned about is the moisture, certainly on a category 4. Not so much on a category 3, but a category 4 you would definitely do that. So that's kind of the one thing. You have an inducer motor that's now going to be used to overcome that resistance of the vent system. So that's another really key important issue to concern yourself with. All right, here's another little bit of a recap on this. So when we look at the vent categories and requirements, this is out of the National Fuel Gas Code Book that is identifying category 1, 2, 3, and 4, and just kind of talking a little bit about how the vent pressures are, whether they're non-positive or positive, whether the temperature is defined as above or below certain certain temperatures, such as like the dew point, and then obviously gas tight, liquid tight, and gas tight. So that's very relevant. Category 3. We definitely have to make that essentially gas tight, but when you start looking at a category 4, now you have to actually, it has to be tight, and it also has to be able to handle the condensate. So those are the things that are fairly important. All right, so let's take a look at a few of the categories. So as I had mentioned, you really have to understand what those rules are and what can I use, how should I apply them, how should they be installed, what's part of the system. So in the image here, I've shown a few different pictures, such as your PVC pipe that's up here. This one is actually considered as a B vent. That's right here, as well as right there. This one here is actually what they call a stainless steel vent type system. And those are systems that you sometimes have to even use those on category 1 appliances. I've had to do that on certain applications where the codes required me to use them. I didn't really see any need to, other than purely a code issue. To me, there would have been no issues with running a B vent, but the code did not allow me to use it, so I had to do that. These are just some other examples showing you the stainless steel type systems. And stainless steel is just a little bit trickier to use, simply because I don't have as much adjustability, but everything is it's really high quality stuff. It can handle the temperature. It can handle anywhere from a category 1 through a category 4, no problem. And the one that's up on here is the polypropylene. And that polypropylene pipe is typically what we would associate using for like a category 4 boiler, simply because the boilers can run fairly high temps and the discharge of those gases. So you could easily see temperatures well above what is acceptable for a PVC vented system. So the choices are essentially either a poly pipe or a stainless steel pipe. And the poly pipe is just it's a little bit easier to work with and much less expensive in many cases.